All right, and we're live. Now, I'm Wesley Workman. I work at Battery, and most of you know me, but today I'm going to talk about promises a little bit, and Ember. So why a talk on promises? So the first time I used promises, this was definitely my response. I thought about it, and I didn't really see what problem they were trying to solve. I had used callbacks, and I didn't really know there was a problem there, and it seemed to add a whole lot of stuff onto a problem that didn't really exist, but I gave it a shot. And so after about an hour of using it, it was very exciting. I could see exactly why you would want to use promises, and we'll talk about that more later. But what really motivated me was after I get to the 2-month mark of using promises that I realized I still didn't know. And the reason I didn't know was because I think I realized that to really use promises, you can't just understand the API, you have to understand all the rules around promises to effectively leverage them. And so that was sort of what motivated me to do this talk. There's also some really great things about Ember and Rsvp that make promises a little bit better than what is in the spec. So we'll start with what a promise is. According to the spec, a promise represents the eventual result of an asynchronous operation. To me, it's a standardized API for encapsulating callbacks. That's what I tell people when I'm introducing them to promises. So some just basic terminology. This is probably mostly a review for many of you. Then is just a method that you hook up callbacks to. I'll show examples of that. Resolved is when the promise is no longer in a pending state. It's when it's been completed. Fulfilled is when the promise was resolved with a successful state. Value is the value that's resolved with a successful state. Rejected is when it's resolved with an error state. And reason is the reason for the error. So this sort of represents the state chart of a promise. It does represent the state chart of a promise. There are really only 3 states, and there's really only one transition that can happen. You go from pending to rejected or pending to fulfilled. Once you're in fulfilled or rejected, there's no more transition that's allowed for that promise. So this is your basic shell example of a promise. It probably looks pretty familiar to most of you. The first part of this is your asynchronous call. Pretty simple. The Ajax call returns a promise. Second part is the then. This is where you're invoking the promise's registration. This is the fulfilled callback, or what I prefer to call the success callback. Rejected, or the failed callback. And it's also really important to note that when you call then, you're returning a new promise. You're not returning the same promise. And that's important later. So promises can be chained. This is really the beauty of promises. This was very much like the first slide or the second slide where I got really excited. Once you figure out how all this works, this is really powerful because I'm finding something from the store or from wherever, and I'm getting the value, and I'm setting a new value on it. I'm saving it again, and then the second then really represents maybe a consumer down the line that doesn't necessarily know how I saved it or what I did. He just knows that some asynchronous action has successfully completed. And here's an example of a chain promise. And this is pretty basic. It's just a random scenario where you've got a function, and he's going to look up for a user that goes on vacation what the weather is going to be like the first day. And so you might think the weather might be a secondary service, and the vacation itinerary might be a primary service. And he's just feeding it through there, looking up the vacation, getting the weather, and returning the temperature. And so for that, I have this slide, this flow chart, and this is actually diagramming what happens with a promise. And the black lines you see across the top are really kind of how you look at it pragmatically, but the blue, green, and yellow lines are how you kind of think about it procedurally in your head, or at least how I do, of how the data flows through. Oh, my cursor shows up, sweet. So yeah, in this case, I've looked up the vacation itinerary, and this P2 here is evaluated right away, but this subsequent promise comes at a much later time. It comes after I've gotten the result of P2, and I'm returning a new promise. Hopefully that makes sense. It's kind of hard to verbalize, but the goal of this is to show that any promise handler can return its own promise or its own chain of promises, and that ultimately becomes part of the whole chain of sequence of events. So you kind of have to do an outer tree traversal of this to really see the order of promises. It's P1, P2, P2.1, and P3, which represents the whole flow of a promise structure. Does that all make sense? So handling rejections. Rejections, like I showed in the first part, it's just the second function, and you just have a reason. And a rejection can be a rejection from a server. It can be some kind of any type of asynchronous operation that might have failed. It can also be an exception. So exceptions are also rejections. And I think that's what sort of took me a long time to figure out, is that you can have an error, or you can have a rejection for normal reasons, but you can also catch an exception as part of a rejection. I think that that's a really powerful thing, because it allows you to recover from that in the same way you might recover from a server error. In this case here, I've just generated an exception, and then my handler just grabbing it right away, and it's going to alert that. Chaining errors. So the other thing, I think I actually have another slide. Yeah, this is much better. So the thing that really tripped me up for a long time was that you really have almost like two tracks. You've got your fulfilled track and your rejected track. And when you've got a series of chained promises, as soon as somebody rejects, like a server reject or an exception, he switches down to the rejected chain, or the rejected track, as I was calling it. And the idea is that the closest rejection will always take the error. So in this case here, the server rejected. This promise itself might have been another asynchronous call, but because the previous one failed, it skips over it, and it goes to the next available rejection handler. Does that all make sense? It's a little hairy, but so this is sort of an important concept to understand for the promises spec. And this, by the way, this all is just the promises spec. There's the second section of this that talks about how you use it in Ember. When you handle a rejection, if you don't throw an error, it's assuming that you've recovered from it. So this is where a lot of people get tripped up, I think. In this case here, I've tried to save data, and the data save fails for whatever reason. And I've done a reset state. Maybe I reset my data back. But the any then promise that's consumed later down the road will actually hit the success. It won't hit the error, even though an error occurred earlier. And the reason for that is because I have this rejected handler. And so if I want that alert to continue propagating down the chain, which in many cases you do, you have to rethrow the reason. And the reason you do that is because if you don't rethrow, the promise system assumes you've handled it. And that means maybe resetting data, but that also really means telling the user. Yeah, does that all make sense? So that's the thing you have to really think about, and that comes into play later on. Generally, if you haven't told the user, you should rethrow it. That's sort of a rule of thumb I've operated under. So one last random rule for promises spec before we go into the Ember stuff is that the onfulfilled and the onrejected handlers from here, they should always operate. They must not be called until execution context stack contains only platform code. What that means is they should be called back when the least amount of things are on the stack as possible. And they do that to always simulate an asynchronous environment. So if you back up to the vacation example that I had here, in this case here, after the weather data has been fulfilled and it's been looked up, I don't need to do another asynchronous operation. I've just done a data transform and I've returned it. But it shouldn't go on and return it from there. It should go all the way back out as far as it can in the stack so that it's essentially simulating an asynchronous action, because if you don't do that, there are times where you could have different conditions based upon different application state, from one thing exiting before another thing finishes. So Ember's Rsvp promises. So everything I just showed up to this point was basically just the basic promises spec. There's not a lot of rules to it, and I did my best to try to sum it up. But it's out there. You can go to the website and see it. It's like A+ promises or something like that. Tilde has their Rsvp promise library, and that's an A+ compliant library that was written for Ember, but it is a micro library that can be used with just Node or anything else. And you use it just with ember.rsvp. So for the rest of this, you see code examples, Rsvp. If you were in Ember, you would do ember.rsvp. So this is essentially how you would create a new promise with Ember, or with Rsvp, excuse me. You just new Rsvp promise, and your first and only argument to the promise is a function handler, and that gives you 2 arguments when it's invoked, resolve and reject, and then you perform your action, and then you either resolve the promise or reject the promise. Rsvp provides a really great way to do concurrent promises. This is one of my favorite features of Rsvp library, is that it gives you a mechanism to do a hash. And so in this case here, I've just said I want to find the user by the user ID, but I also concurrently want to find the post by the post ID. And I don't want them to be consecutive. I just want them to be looked up, and then you can tell me when they're both done. And it combines that into a promise that passes me a hash as the value. So there's hash and there's hash settled. Hash will give you, we'll call the promise when all of them have succeeded or when one has failed. Hash settled will call you when all have succeeded or all have failed. So the difference in use case really is how you want to handle the failure. If you want to fail early, or if you want to wait till everything is done and then fail. There's an all and an all settle. And very much like hash, it's the exact same set of mechanisms. The only difference is that it works on a list instead of a predefined hash of promises. And this is good for an undefined list of promises. And same with all and all settled. All is when they've all completed or when one has failed. All settled is, when they've all completed or they've all failed. And it just gives you a value that has 2 properties. It gives you a value that's an array. And each array item has a state, fulfilled or rejected. And then depending upon that state, it has either reason or value. And so this is a way you can really handle a lot of bulk things as promises concurrently. And so we do this in our app, and I have an example of that later, I think. Finally, finally is a function hook that's provided by Rsvp that you can do cleanup. And that is not part of the promises spec, it's just a convenient function. So in this case here, I'm saving a post, and I've got my 2 resolved and fulfilled and rejected handlers, and then I've got a finally call. And the nice thing is that finally call is always fired, regardless of whether there's a success or an error. And so it just allows me to reset my state really easily. And so, with similar diagrams before, finally is always called when it's passed over, regardless of anything else, regardless if there are chain promises after it or anything before it that is errored or success. It's always called. So it's just a nice way at a consumer, at like a encapsulated level to do cleanup after a set of promises. But you can have a continuation of those promises by another consumer. On error. So this is my favorite part of Rsvp. And Rsvp has a mechanism to alert Ember when there's been a promise that was rejected and nobody handled that rejection. So if you imagine an Ajax call that failed on the server, but nobody handled that failure. Nobody told the user about it. So you can subscribe to that in Rsvp, but by default, Rsvp will call ember.onError, and it will tell you about that. And I have a JS-bin example of that. So in this case here, I've got a localized error. Let me blow this up. Maybe that's 2. Let's see. That'll work. So I've got a localized error generator and what I'm calling a global error generator. The localized error generator simulates an Ajax call, and it handles the Ajax failure, and it sets the reason on the controller, and then it takes off in 3 seconds. So This is what happens, under normal Ajax conditions when you've handled an Ajax error. And the global Ajax error, generate global error will simulate an Ajax error that fails, but nobody handles it. And in that case, it ends up propagating through Ember.on error, and I am accessing an alert service that I have, and it sends the error to the alert service. And the alert service just stores the value, and in my application template, I bound to that alert service. So that whenever there's a global error that's been completely unhandled by anybody, I still have a way to message the user about it. And so that's really why you always want to rethrow the error if you haven't told the user about it, in my opinion. That's sort of my rule of thumb. That way somebody else can consume it later. Even if you've sort of done cleanup, rethrowing still allows somebody else to inform the user. So I went through that really quick, and that's really all I had.
Can you go through your last example one more time? I didn't
Sure.
make the buttons smaller. I want to see the difference between the local and global, how it was generated.
You may make the code smaller, I'm sorry?
Oh, I meant get the buttons smaller so I can see the code bigger.
Like this part?
Oh.
Oh. Okay, sorry. Sure, so I have this simulate Ajax reject function, and I'll show him. Down here, he just makes a new promise, and in 500 milliseconds, he just rejects the promise. So it's simulating any kind of error. On the local one, there's this handler right here. So this is if you ever look inside of Ember, sometimes you'll see a then with a null at first. And what they're doing is they're just not handling the success. They just want to handle the error. And the reason they do that is because they have nothing to do with this success. And if you were to put like ember.k in place of that, any value that would pass through has to be returned on a success. So if you were to put like ember.k here, just an empty function, and a successful promise went through, that would essentially swallow your value. The promise would continue to succeed, but the value had been swallowed. So that's why you put null there. But yeah, so essentially this is the error handler, and he's setting the local error to the string value, and then in 3 seconds he's just clearing it out. And then this guy right here is just a progress thing for the spinner. So executing it again just does that. This right here, maybe I should have designed this better, but this is sort of the index route. This was meant to represent sort of a localized resource here. And up here is the application route. You probably can't even see it, but there's an HR on my screen anyways that is splitting those. And so when I generate the global one, it does the same simulation, but nobody actually handles it. There's no then to handle that error. And so it bubbles up through Ember.on error. And then that guy is shoving it into his service.
Yeah, that's what I was wondering. Because if you don't do anything like you did there, you still get it. It's just a global error.
Yeah, yeah. So
that's not a promise, and that's an Rsvp thing.
that is definitely an Rsvp thing. That is not a promise spec. The promise spec is very minimal. It's more about the rules of chaining promises than it is anything else. It doesn't say anything about all the all settled or the hash or even finally. It's not a plus thing. So I guess what I was trying to articulate earlier was that if you were to do something like this here, function. Anyways, if you were to handle the error here, but not alert the user, it would not bubble up. So like clicking global here has no effect because even though I didn't alert the user, I just cleaned up some maybe transient state, it's still been swallowed. So in order to continue to propagate that, you want to throw the reason. and now it continues to propagate. So a further consumer that might have another then down the line could handle it, or eventually the global one handles it.
Did I hear you right? You can chain a then after a final?
Yep, you can chain a then after a finally. So in this case here, I have, let's see, let's get rid of this finally.
And that'll get the return value of the last then, not the finally.
Yes, it'll get, let's test that. It should get whatever value was either in the error track or the success track. So in this case, it would be an error. So Ajax error, yeah. Yep. So we do that a lot in our code, where we hit a lot of specific endpoints for either bulk things or more complex actions. And at one level, we'll have a spinner, and we'll say, is processing, do this stuff, and then finally, turn off the spinner. And then the promise continues on down the chain to the person that really needed to consume it.
One question I've always had, and I just should have tried it, but like I use the catch syntax a lot. So instead of doing then and putting two functions, I'll do then input the success function and then catch input the catch function. You know what I'm talking about?
No, I don't. I'm sorry.
So like on your final then there, like
Yep.
if you just close the function call after null,
Okay.
and yeah, leave all that still.
Okay.
Just close it after null and then
Okay.
do dot catch
Oh.
and then open, and then you can drop that and it does the same thing.
Oh, interesting.
So you can it makes it a little bit cleaner looking when you're trying to follow it down the line.
I did not know that the dot catch was there. That must be an Rsvp thing.
So my question has always been like, if I throw a catch right in the middle of my string of like dot then, dot then, dot then, dot catch, dot then, dot then, dot catch, or something like that, I suppose it would probably function exactly the same as the like full then.
Yeah, I mean, I think in this case it would. So if you did dot catch here, so it gets the error, but my guess is it essentially swallows it. So like this would be a no op.
Yeah.
But if you were to throw it again, it would continue propagating.
I think there is a difference if that then had a success handler. If you do then with two functions, then I think the rejection handler would not be called if success handler threw an exception. But this way I think would, because it's after.
So you're saying if it was a successful promise, you think the catch would still handle it?
No, if your then had a success handler and a failure handler.
Yep.
But your success handler threw an exception, then the failure handler on that then would not get called.
I think that's true.
But
But if you did not catch after,
Yeah.
then it would.
But it would also be the same as having another dot then
Yeah.
with a null.
Yeah,
Yeah.
it's syntactic sugar for a then when it's undefined is the first argument.
Okay,
Okay.
interesting. I didn't know that it was there. Learned something new.
It can be like a blessing and a curse though, because of exactly what you're saying there. Like you throw the exception in your own code and you're handling an Ajax error in your catch.
Yeah.
So, then you have an exception in your own code and then bubbles down to your catch, and you're trying to catch Ajax errors.
Yeah.
So you probably, if you want to catch an Ajax error from the initial call, you probably want to put your catch above the dot.
Yeah. What we actually started doing to help, because we have a global application handler like this, and what we did to start helping that was at the adapter layer, we build our own error. We wrap up the Ajax error, and that guy, his goal is to try to find an error message. He contains all of the original data, but he tries to pick out an error message based upon our error validation stuff from the server. And so if the particular controller that called that Ajax doesn't know how to handle it or forgets to at some point, the guy that gets all the way to the end on the on error has a normalized way to try to handle the error. And so in some cases, in the client, we also would do, like, if we were to throw, we might throw, like, wrap up an error the same way and throw that. And so the guy at the end really is just looking at, like, one property on this object to try to figure out the string. Otherwise, that Ember.onError ends up having to know, like, dozens of different things about the application and where the error came from.
We have our, like, Ember on errors. Essentially, like, they're just to throw errors to, like, our logging
Yep.
reporting
Yep.
services.
Yeah, we do the same thing. So anything that's like, it's not an Ajax error or a validation error, it's like a stack exception, we use Ember.onError to log that. So that's sort of the nice thing about Ember, the fact that everything is in a promise internally to all of its run loop stuff, is that it automatically gets caught that way. Any exceptions that we see end up in that Ember.onError. Any more questions?
How about, like, have you ever used promise array or promise object in your data stuff?
Yeah, so that was one thing I almost brought into the talk, but I didn't, because I didn't want to confuse a lot of people. But it is pretty crazy. Has anyone seen the promise array stuff? So the promise array is essentially, it's both an array and a promise. And it's an Ember data convention for how they handle relationships. So like any sort of object that you might want to lazily load, and you want to get the advantages of the promise so that you know when it's fully done and you can take some pragmatic action. But you also want to get the advantages of just being able to bind to a value and having it show up. So it's essentially a proxy that proxies the array or the underlying object through, but it also acts as a promise. So it can be very handy in some cases, but it can be very confusing in other cases.
It feels like it kind of feels like the model hook to me a lot of times. For the fact that, like,
Yeah.
you're returning a promise to the model hook, but then everybody else treats it as if it's the actual
Yes.
return value.
Yep. Yeah, absolutely. Cool. Well, I think that's all we got.